Hi everyone. Today I'm going to talk on the topic light, reflection and refraction. We know light is a form of energy. It travels in a straight line. It is an electromagnetic wave. The common phenomena of light are formation of shadows, formation of images by mirrors and lenses, bending of light by a medium, twinkling of stars, formation of rainbow. These are all because of the light. So you see, we can see the objects only because of the reflection of light. So the light just strikes on the object and we see it. So in this topic, we are going to discuss in detail about reflection of light. What is reflection of light? When light falls on a highly polished surface like a mirror, most of the light is sent back into the same medium. This process is called reflection of light. Okay. Now there are two laws of reflection. The first law is the angle of incidence is equal to the angle of reflection. You see, this is the normal line on the surface. So here the light is striking with an angle theta. We can see here, and it is getting reflected with an angle theta. These two angles are always equal. This angle and this angle are always equal. Then the second law is the incident ray, the reflected ray, and the normal to the mirror at the point of incidence all lie in the same plane. So if you take any plane, you see your mobile surface is a plane. If you make a light to travel on the surface of your mobile, then it will be traveling on the surface only. It will not move away from it. So that's what the incident ray, the reflected ray, the normal at the point of incidence all lie in the same plane. All lie in the same plane. For example, just I will tell you, I will show you on a surface. Can you see the surface now? You see, this is the surface. So, if a ray of light traveling in this way, then it will be reflected and traveling in the surface itself. It doesn't go like this or like this. We know the best reflecting surface is the mirror. Now the mirrors can be classified into two. One is plane mirror, another one is spherical mirror. Now let us discuss on plane mirror. We all know what is plane mirror. Every day we see plane mirror. So the image formation in case of plane mirror will be in this way. The image is erect. If we stand in front of the mirror, the image also will be standing there. So it is erect. The point number two is the image is same size as the object. If the object size is 5 meter, the image size also will be 5 meter. The third point, the image is at the same distance from the mirror as the object is in front of it. See, you can see here. So here is an object and this is the image. The distance between the object and mirror and the image and mirror will be always same. The fourth point, the image is virtual. What is virtual image? It cannot be formed on the screen. If we stand in front of the mirror, our image can be seen. If we just move from the mirror, then image also will be moved. The image will not be staying there. So it cannot be formed on the screen. That is virtual. The image is laterally inverted. What does it mean? In this figure you can see, so here the left hand is shown, but from the mirror the right hand is seen. So this is called laterally inverted. Let us now discuss on spherical mirrors. There are two types of spherical mirrors. One is concave mirror, another one is convex mirror. In concave mirror, the reflecting surface is curved inward. So this is the reflecting surface. In convex mirror, the reflecting surface is curved outward. So this is the reflecting surface. We should know few terms related to concave mirror. So the first one is center of curvature. Center of curvature. It is the center of the sphere of which the mirror is a part. So you can see here, this is the center of curvature, and if you consider this as the concave mirror, then the center of this will be somewhere here. So this is called center of curvature. Next, radius of curvature. It is nothing but the radius of the sphere in which mirror is a part. In which mirror is a part. The third one is pole. So this point is called pole. The center of the mirror is called pole. This is called pole, we can say. Pole. Okay. Now, principal focus. This point is called principal focus. So, what is principal focus? In a concave mirror, rays of light parallel to the principal axis after reflection meet at a point on the principal axis called principal focus. The parallel rays coming from infinity strike on the concave surface and they get reflected and get concentrated at a particular point on the principal axis. That point is called principal focus. Now let us see what is focal length. It is the distance from focal point to pole. This is called focal length. Now let us discuss some important rules for drawing the ray diagrams. In a concave mirror, a ray of light parallel to the principal axis after reflection passes through the focus. So the ray which is coming parallel to the principal axis after reflection passes through the focus. This is one rule. In a convex mirror, a ray of light parallel to the principal axis after reflection appears to diverge from the focus. So here the ray is going like this and it gets reflected, but the reflected ray appears as if it has come from the focal point. This is actually focal point. Like this. In a concave mirror, a ray of light passing through the focus after reflection goes parallel to the principal axis. You see, the ray is passing through the focal, then after reflection it goes parallel to the principal axis. So here also you can see in convex mirror also, the ray is coming, it appears as if it is going to focal point and it reflects back and goes parallel to the principal axis. So this is the second rule. This is the second rule. So the first rule, the ray which is traveling parallel to the principal axis after reflection goes through F. The second rule, if any ray going through the principal focus after striking on the mirror, it reflects back and goes parallel to the principal axis. The third rule is, in a convex mirror or in a concave mirror, a ray of light passing through the center of curvature after reflection is reflected back along the same direction. So if any ray is passing through C after reflection, it retraces its original path. So it's going like this, then again it will come back. So if any ray passing through the center of curvature gets reflected back. Use of spherical mirrors. Concave mirrors are used in torches, searchlights, headlights of vehicles to get parallel beam of light. They are used as shaving mirrors to see larger image of the face. Concave mirror I am talking about. They are used by dentists to see larger image of teeth. Large concave mirrors are used to concentrate sunlight to produce heat in solar furnace. This is solar furnace. So it is, you see, torchlight, searchlight, headlight, shaving mirror, dentist they use, and it is used in solar furnace. Convex mirrors are used as rear view mirrors in vehicles. Convex mirrors give erect, diminished image of objects. They also have a wider field of view than plane mirrors. I hope you understood about uses.